Hello everyone, welcome back to Through Deviations. As you can remember, in the last video, we covered the beginning of Unit 3, which was talking about the theory behind finding maxima and minima values, maximum and minimum values of functions. May have been a little bit of review, but today we're going to be going full on with the calculus and using what we know about differentiation to apply it to what we know about maxima and minima. And this is really setting us up for something called an optimization problem, where we can use these polynomial functions and trig functions to model a situation that we need to optimize. But that comes a lot later in Unit 3. But that's something to be thinking about as we go through this unit. As always, please rewatch any videos if you feel rusty on anything with differentiation. Let's get started. So we are going to begin with a quick recap of what we talked about in the last video, just so that we're fresh on what we are going to be covering. So we are going to be covering Fermat's theorem a lot today. So by Fermat's theorem, our maxima and minima of a differentiable function, that's important, differentiable function, exist where the first derivative is equal to 0. Okay, so what they're really saying is if I have a polynomial function here, I'm going to obviously have an absolute maximum here, and then I'll have an absolute minimum maybe somewhere down here. But that's not important right now. What's important here is if I want to find my local maximum values and minimum values, what Fermat's theorem says is that I'm going to find those where my slope, or my derivative, equals 0. So we can do that by setting our derivative equal to 0, and that's a really powerful tool. So we can find the maximum values and the minimum values with Fermat's theorem. Alright, so now let's do an example with this. They're telling us to find the critical numbers of f of x equals x to the 3/5 times 4 minus x. Alright, so first what we're going to need to do is we're going to need to find the derivative. So what we're going to do is we're going to use the product rule, and once we're done differentiating that, we're going to get an answer of f prime of x equals 12 minus 8x over 5x to the 2/5 power. And I'm sure there are a lot of different ways you could write that out. Anyways, now we need to set this equal to 0. And as you recall, we are only going to be dealing with the numerator up here. So with the numerator up there, we are going to set f prime of x equal to 0. That means 12 minus 8x is equal to 0. And now what we will do is we will state our critical numbers. So we're going to have a critical number at 3/2 by this equation here, but then also at 0, since our f prime function is not defined at 0. So those are our critical numbers of our function. That's all we need to do for that example. Now we're going to cover something else that's going to be fairly helpful for our next examples. This is called the closed interval method. To find an absolute maximum and minimum values of a continuous function f on an interval a to b, a closed interval ab, find the values of f at critical numbers on AV, excluding the endpoints. And then we find the values of f at the endpoints, because there might be a situation where I might have an interval here, AB, and it looks something like this. And I'll find my critical numbers, and then just with differentiation, I'll say, okay, so I've found the absolute maximum and the absolute minimum with Fermat's theorem. But that's not true, because you need to make sure you're checking the endpoints, because this maximum is greater than this maximum on this interval, and this minimum is less than this minimum on the interval from A to B. And then we are going to determine the absolute minimum and absolute maximum based on which is greater and which is less. Let's clear that up. So in this example, we are going to find the absolute minimum and maximum of x cubed minus 3x squared plus 1 on the interval from -1/2 to 4. So first, as always, we need to find our derivative, and this is pretty easy. We just have a nice cubic polynomial here, and that gives us f prime of x is equal to 3x squared minus 6x. And we will set that equal to 0 and factor it. We'll get some linear factors, meaning that we can solve for x, giving us x equals 0 and x equals 2. Great. So now let's take a peek at our endpoints, negative 1/2 and 4. So f of negative 1/2 is going to be 1/8 if we plug that into our polynomial. And then f of 4 will be 17 if we plug that into our polynomial. Okay, so now let's find the values of f at our two critical numbers that we found here. And that will say that f of 0 is equal to 1 when we plug that into our function, and then f of 2 will be negative 3 when that is plugged into our function. Okay, so now we need to determine what our absolute maximum and absolute minimum values are on our interval. Okay, so the greatest out of this set of 4 is 17. So that means that f of 4 is our absolute maximum. And then our lowest in the set is going to be negative 3, meaning that f of 2 is our absolute minimum. So what we can say here is our maximum is f of 4 at 17, and our minimum is at f of 2 at negative 3. So that is how we do a problem like that. But in case you didn't get the idea, why don't we do just one more? So we are going to find the absolute maximum and minimum of x minus 2 sine x on the interval between 0 and 2 pi. Okay, so this is an example that involves a trig function. So first, as always, we're going to take our derivative, our first derivative. F prime of x is equal to 1 minus 2 cosine x. And then we set that equal to 0. And then when we use the cosine, that will give us x equals pi over 3 and 5 pi over 3. So let's try finding the values at our critical points that we found here first. So f of pi over 3 will be pi over 3 minus root 3, and then f of 5 pi over 3 will be 5 pi over 3 plus root 3, probably bringing back a little bit of your cosine expertise of finding your values there. Okay, so now let's take a peek at the endpoints of 0 and 2 pi. So f of 0 will result in 0, and f of 2 pi will result in 2 pi. So those are our results for that. So now we can take a peek to see what's the largest and which is the smallest. So the largest in the set is going to be 5 pi over 3 plus root 3. So that's our biggest in the set. So that's our max. And then our smallest value is, well, this is our only value here that we're going to find for a minimum. So that is the smallest in the set. It's the smallest in the set. So that is our min. And then we can just rewrite this as a clause at the end that our maximum is f of 5 pi over 3, which is 5 pi over 3 plus root 3, and our minimum is f of pi over 3, which is equal to pi over 3 minus root 3. Okay, that is our video for finding the absolute maximum and absolute minimum on an interval of polynomial and trig functions. In the next couple of videos, we're going to be diving back into some theory involving some more theorems, the first which will be Rolle's theorem, which will lead to another video on the mean value theorem. So that is all to come. See you guys in the next one.